We all know submarines to be any naval vessel or ship that is capable of propelling beneath the water or on the water surface. Its purpose is to patrol the ocean waters and attack enemy ships during the war. Submarines are also used for inserting and removing military forces in special operations, intelligence gathering, and rescuing aircrew during air attacks on islands. It is very strategic that when airmen meet casualties, they would be told of a safe place to land so the submarines can rescue them. Submarines are large in size, and they can carry more than 100 people on top of weapons such as missiles and torpedoes. More than this common knowledge, what else do we not know about these submarines? What happens when crews in submarines get into trouble? What are the Navy's preparation and strategies to make submarines operations leverage against the enemies? Join us in this video and find out more about the technologies and training developed for rescue operations in submarines. Submarine rescue is a challenging part of the naval tactics and operations since there are many possible variables to consider since the sea is a difficult and unforgiving element of nature. And seas, as its very nature, is harder to operate during emergency situations. This is true since any submarine accident comes with different causes and solutions. But how does the Navy ensure that submarines get rescued from the bottom of the ocean? The Navy is very vocal about its dedication to ensuring that its crew and volunteers are safe during their operations. In fact, naval forces partake in a live submarine search, escape, and rescue exercise every 3 years. They call this exercise the Dynamic Monarch Exercise. During Dynamic Monarch Exercise, NATO allies and other nations come together to train and exchange knowledge on saving crew members from troubled submarines. This rescue system exercise involves thousands of military personnel and civilians who develop tactics and test out the latest equipment and procedure in handling a submarine operations crisis. Trainers always emphasize that this exercise is not a war exercise but a rescue exercise, that is, saving the life at sea. Given the challenges in marine operations, technologies have been developed and upgraded to make rescue operations more efficient and effective. Such technology is the atmospheric diving suit, also known as atmospheric diving system. Initially reported to be able to dive 60 feet deep, it has been developed to be able to dive up to 2,300 feet with higher mobility. It can also eliminate the majority of physiological dangers associated with deep diving. This suit is a humanoid type deep sea manned operation system that can maintain atmospheric pressure. It is a small one-person submersible that allows the diver to directly reach the operation site for observation, navigating by the underwater thruster or landing and shifting on its own. Equipped with rotary joints, the driver can control the gripper of both hands and special tools used in underwater operations. The suit is connected to the tether management system using the neutral cable to obtain energy and communicate. This allows the video image of the operation process to be transmitted to the surface ship for reference. Another technology is the yellow SRV-300, which is the main payload for the submarine rescue service. This submarine rescue ship can operate at a depth of 984 feet. It has a displacement of 27 tons and can carry 12 passengers in the rescue compartment. Its latest update, called the SRV-300, can reach a maximum depth of 2,133 feet and can carry 15 people in the rescue compartment. US Navy also joined the Dynamic Monarch exercise and developed their Submarine Rescue Chamber. Submarine Rescue Chamber consists of 145 personnel, 45 active duty officers and enlisted officers, and 100 contractors and reservists. This chamber is designed to rescue 6 submariners from the bottom submarines from a depth of 850 feet. It works by connecting a submarine's escape hatch to the distressed submarine. The lower compartment of the chamber is cleared of water before it is released into the upper compartment and vented to the surface. Once done, the hatch can be opened and the trapped submariners can enter the rescue chamber to safety. We have been talking a lot about this NATO submarine rescue system, but what exactly is this system? As the Scottish Communications Group defines, NATO Submarine Rescue System, or NSRS, is a tri-national project to develop an international submarine rescue system. It is managed by the United Kingdom's Ministry of of Defense on behalf of France and Norway. This system provides a rescue capability to NATO and allied nations, and to any submarine equipped with a suitable matting surface around its hatches. NATO's SRV-1, designed and built by Perry Slingsby System Ltd. of Kirkby Moorside, is manned by 2 pilots and an attendant and can rescue 15 people at a time. It normally operates in a 4-hour cycle, with an expected cycle of no more than 72 hours from its deployment anywhere in the world. This system is fitted with a fiber optic umbilical to provide video communications and data links to the operators on the surface of the sea. It is also equipped with 3 components: the intervention system, the rescue vehicle, and the transfer under pressure systems. This can even work unseen, unheard, and undetected, thereby naming this elusive submarine operation to be the silent service. And while we talk about the technologies and the systems of submarine rescue, we also have to mention the people behind this. These technologies are operated by selected and trained US Navy volunteers who must undergo 3 phases of physical training and testing, on top of their academic and technical training. Submarine schools also provide basic theory on the build and operation of nuclear-powered submarines. This is to ensure that the selected and trained volunteers can adapt to the intense pressure between the surface and the operating depth of the submarine. Aside from all these, volunteers are trained to conduct firefighting and damage control for emergency purposes. Part of the practical training course also includes the escape mechanism from a disabled submarine 40 feet below the sea surface. These volunteers are even subjected to mental and physical evaluation and monitoring to make sure that they can cope with the danger and lethal possibilities when they are in the submarines. Basic Enlisted Submarine School, or BESS, offers this training. It is the US Navy Submarine Training School for enlisted sailors. This school is an 8-week introduction to the basic theory, construction, and operation of nuclear-powered submarines. The training course includes instruction on shipboard organization, submarine safety, and escape procedures. This training, though, is not just basic theoretical training. Instead, this school provides real-life and modernized simulation so enlisted personnel and officers get familiarized with the real submarine operation. More than the course itself, this program requires passing a physical and mental screening. Sailors who wish to join the submarine force are required to complete the 2-month program. Imagine the commitment of these submariners. They have to undergo such intensive training and be put in the volunteer position. The risk of the job itself is never underrated, so their work and commitment to naval force and safety are truly commendable. Kudos to you, all submariners. Kudos to our 5,000 officers and 50,000 sailors who represent the US Navy Submarine Force. This in itself is the Navy's leverage against the enemies. Truly, the technologies incorporated in the updates of the submarines and the training of the very few selected officers and volunteers make the naval core values of honor, courage, and commitment strong. So the next time we see or think about submarines, we will not only think of them as any ordinary naval vessel or ship. Rather, they are a picture of dedicated people behind the submarine operations and technological systems.